Hello everyone, this is Kalpana here. In this video, we are going to prove a problem from mathematical induction. So let's get going. Problem: prove that for any natural numbers n, a power n minus b power n is divisible by a minus b where a is greater than b. Solution. So here we are asked to prove that this statement is true for any natural number n provided a greater than b. Okay, so any value a must be a value which is always greater than b. Okay, so let's see. Let p of n be the given statement. Let p of n be the given statement. Then that is p of n, a power n minus b power n is divisible by a minus b for all n belongs to natural numbers and a greater than b. So firstly we'll show that p of n is true for some n equals to 1, 2, so on. Okay, natural numbers. We'll check whether p of n is true or not for n equals to 1, 2 and all. Okay, and we'll assume that p of n is true for n equals to k, and later we'll prove p of n is true for n equals to k plus 1. So let's see. When n equals to 1, a power 1 minus b power 1. Consider a power n minus b power n, and we'll check whether the statement is true for n equals to 1 or not. That is, a power 1 minus b power 1 must be divisible by a minus b. Okay. So a power 1 minus b power 1 is a minus b. Right. A power 1 minus b power 1 is divisible by a minus b. Since a power 1 minus b power 1 is a minus b, and a minus b into 1's a minus b. So from this we'll get remainder 0. So here 1 is a quotient. We know that divisor into quotient plus remainder gives dividend, right? Divisor into quotient plus remainder gives dividend, right? Then you can write divisor into quotient 1 plus remainder 0. From this you have to get dividend a power 1 minus b power 1. So let's see what happens. From this you will get a minus b, right, which is a dividend. So here we are having quotient, divisor into quotient plus remainder equals to dividend, right? Then divisor into quotient equals to dividend minus remainder. Okay, again you'll get quotient equals to dividend minus remainder by divisor, right? So you can write this as, that is dividend as dividend minus remainder is 0 by divisor, which gives quotient. right? Simply we'll write this as a minus b into 1. Okay, we can write a minus b as a minus b into 1, which is a multiple of a minus b. And also, since this is multiple of a minus b, also it is divisible by a minus b, right? A minus b. See, a1 minus a power 1 minus b power 1 is a minus b, and it is divisible by a minus b, right? Since a minus b is multiple of 1, and also it is divisible by a minus b. A minus b into 1 is a minus b, divided by a minus b gives quotient 1. And also divisible by a minus b. So a power 1 minus b power 1 is divisible by a minus b. From this we can say that p of n is true for n equals to 1. Therefore, p of n is true for n equals to 1. From this we can say that p of 1 is true. Likewise, we can prove for n equals to 2. When n equals to 2, put n equals to 2 in a power n minus b power n. Now we have to show that a square minus b square is divisible by a minus b. We know that a square minus b square can be written as a plus b into a minus b. You can also write this as a minus b into a plus b, which is a multiple of a minus b, right? A square minus b square divided by a minus b gives. We can split. Okay, you can write a square minus b square as a plus b into a minus b. So a minus b into a plus b gives a plus b into a minus b with remainder 0 here. A plus b is a quotient, right? This is quotient. And a square minus b square is a multiple of a minus b. Since it is a multiple of a minus b, so it is divisible by a minus b. Already we have seen here, right? Which is a multiple of a minus b, and also divisible by a minus b. If you divide a square minus b square by a minus b, you'll get remainder 0 with quotient a plus b, right? So therefore, p of n is true for n equals to 2. From this we can say that p of 2 is true. Likewise, we can show for n equals to 3. For n equals to 3, we'll get a cube minus b cube. Now we have to show that a cube minus b cube is divisible by a minus b. Since we know that a minus b whole cube equals to a cube minus b cube minus 3ab into a minus b. Now bring minus 3ab into a minus b to LHS, will get a minus b whole cube equals to, plus 3ab into a minus b equals to a cube minus b cube, right? Now we can replace a cube minus b cube by a minus b whole cube plus 3ab into a minus b. Now take a minus b common from these two terms, we'll get a minus b times a minus b whole square plus 3ab, right? Which is again a multiple of a minus b. So by looking at this, we can say that a cube minus b cube can be divisible by a minus b. A cube minus b cube is a minus b into a minus b whole cube, square plus 3ab divisible by a minus b. So a minus b into a minus b whole square plus 3ab gives a minus b into a minus b whole square plus 3ab with remainder 0, right? So we can say that a cube minus b cube is divisible by a minus b. Quotient a minus b whole square plus 3ab. So this is a quotient. Terms under square brackets is a quotient, right? And also it is a multiple of a minus b, which is a multiple of a minus b, right? And also divisible by a minus b. Since a cube minus b cube is divisible by a minus b with a quotient a minus b whole square plus 3ab, right? So we can say that the statement is true for n equals to 3. Therefore, P of n is true for n equals to 3. Therefore, P of 3 is true. Now, we'll assume that P of n is true for some n equals to k. That is, P of k is true. That is, P of k will be a power k minus b power k is divisible by a minus b. See, every time we got multiple of a minus b, right, with quotients. Likewise, for P of k, we'll get a power k minus b power k equals to multiple of a minus b with some quotient. Okay. If a power k minus b power k is divisible by a minus b, then a minus b into some coefficient gives a power k minus b power k, so that the remainder becomes 0, right? So let's consider this coefficient as some lambda or some q, better. Q for coefficient, right? Then a power k minus b power k equals to a minus b into q, right? So here you can write now take minus b power k to RHS, you will get a power k equals to b power k plus a minus b into q, right? Now consider it as some equation 1. If you multiply both sides with a, then you will get here you are having power 1, right? Add the powers, you will get k plus 1, a power k plus 1 equals to a into b power k plus a minus b into qa, that is aq into a minus b, right? Consider as equation 2. Now we can prove p of k plus 1 is true whenever p of k is true. That is, we'll prove p of k plus 1 is true using this condition. A power k minus b power k is divisible by a minus b. Since a power k minus b power k is divisible by a minus b, from that we'll get these two equations. Okay, we can use any of these two equations to prove p of k plus 1 is true. So let's see how we'll get. Now for n equals to k plus 1, a power k plus 1 minus b power k plus 1. We have to show that a power k plus 1 minus b power k plus 1 is divisible by a minus b. Right? Now, you can split a power k plus 1 as a power k into a and b power k plus 1 as b power k into b. Now replace a power k by first equation, then you'll get b power k plus a minus b into q into a minus b power k into b. Now you'll get a into b power k plus a minus b into qa, that is qa into a minus b minus b into b power k. Now write the terms involving b power k firstly. You'll get a into b power k minus b into b power k and the remaining term aq into a minus b. Now we can take b power k common from these two terms. You'll get b power k times a minus b plus aq into a minus b, right? Now let's take a minus b common from these two terms. You'll get a minus b times b power k plus aq, which is a multiple of a minus b. Okay. For n equals to 1, 2, 3 and k, we got multiple of a minus b with some coefficient, right? Likewise, here b power k plus aq is also a coefficient. Okay. If it is divisible by a minus b, then a minus b into b power k plus aq gives a power k plus 1 minus b power k plus 1, right? With remainder 0. Or in detail, since a power k plus 1 minus b power k plus 1 is a minus b into b power k plus aq, right? So a minus b into b power k plus aq gives a minus b into b power k plus aq, right? With the remainder 0. So here we can say that b power k plus aq is a quotient, and also divisor into quotient plus remainder gives the dividend. It is nothing but a power k plus 1 minus b power k plus 1 is divisible by a minus b. Okay, from this we can say that a power k minus b power k is divisible by a minus b with quotient b power k plus aq. So we have already used the quotient symbol q earlier for n equals to k. So now let's consider b power k plus aq as some lambda. Okay, let or where lambda equals to b power k plus a into q. Okay, now we'll see for this one, the second equation. Replace a power k plus 1 by equation 2, then you'll get a into b power k plus aq into a minus b power k. B power k plus 1 can be written as b power k into b. Now write the terms involving b power k, right, plus the remaining term. Now we can take b power k common from these two terms. You'll get b power k times a minus b. Now let's take a minus b common from these two terms. You'll get a minus b times b power k plus aq, where b power k plus aq is lambda, since this is a quotient, right? We'll get the same thing by using either 1 or 2. A minus b into lambda. So here we have a power k plus 1 minus b power k plus 1 equals to multiple of a minus b with some quotient lambda, right? Which is a multiple of a minus b, also divisible by a minus b, right? So a power k plus 1 minus b power k plus 1 is divisible by a minus 1, right? You'll get quotient lambda. Therefore, P of n is true for n equals to k plus 1. From this we can say that P of k plus 1 is true. So by the principle of mathematical induction, the given statement is true for all n belongs to natural numbers and a greater than b. By the principle of mathematical induction, P of n is true for all n belongs to n and a greater than b. We'll see why we are given a greater than b. What happens if a is greater than b? If we consider a, b are natural numbers, For a greater than b, we'll choose some a which is greater than b. Say a equals to 4 and b equals to 2. Then a minus b will be 4 minus 2 which is equals to 2. Okay. When n equals to 1, put n equals to 1 in a power n minus b power n. Then we'll get a power 1 minus b power 1 which is a minus b. That is 4 minus 2 which is equals to 2. Now we'll see a power 1 minus b power 1 by a minus b. That is a power 1 minus b power 1 is divisible by a minus b or not. Since a power 1 minus b power 1 is 2 divided by a minus b is 2 equals to 1, right? Let it be 1. Now, when n equals to 2, a square minus b square. For a equals to 4 and b equals to 2, we will get 4 square. For 4, 16 minus 2 square. 2 2s are 4 which is equals to 16 minus 4, 12. Now we'll see a square minus b square is divisible by a minus b or not. We'll get 12 by a minus b is 2 which is equals to 6. Right? Now let's see for n equals to 3. For a equals to 4 and b equals to 2, we'll get a 4 power cube is 4 4 16, 16 4 64 minus 2 cube, 2 2s are 4, 4 2s are 8. 64 minus 8, 56. We'll see a cube minus b cube is divisible by a minus b or not. 56 by a minus b. 2 gives 2 2s are 4, 2 8s are 16. Right? 26. Which is divisible by a minus b. (28), right? 2 28s are 56. So here a cube minus b cube is divisible by a minus b with quotient 28. So here 1 is the quotient obtained when n equals to 1, and 6 is the quotient obtained when n equals to 2, and 28 is the quotient obtained when n equals to 3, which are positive, right? So we can say that 1, 6, 28 and so on are natural numbers, right? Then we'll get all the quotient which are or which belongs to natural number. So we can say that Q belongs to natural number and also lambda belongs to natural number. So whenever a, b are natural numbers, for a greater than b, we'll get quotient which belongs to natural numbers. Okay. Now let's see for integers. So I'll take two integers, say a equals to minus 2 and b equals to minus 4, where a is greater than b. A minus b is minus 2 minus of minus 4. Minus into minus plus, so minus 2 plus 4 is 2. So when n equals to 1, you'll get a power 1 minus b power 1, which is equals to 2. Okay. Now we'll see a power n minus b power n by a minus b. That is, a power 1 minus b power 1 is divisible by a minus b or not. Gives a power 1 minus b power 1 is 2 divided by a minus b is 2. So you'll get the quotient 1. Okay. When n equals to 1, you'll get quotient 1. And when n equals to 2, we'll see a square minus b square is divisible by a by b or not. Okay. So a square minus b square is minus 12 by a minus b is 2, which is equals to minus 6. So when n equals to 2, we'll get the quotient minus 6. Now, for n equals to 3, we'll take whether a cube minus b cube is divisible by a minus b or not. A cube minus b cube is 72 divided by a minus b. 2 is 2 3s are 6, 2 6 are 12, 36. Okay. So when a power n minus b power n is divisible by a minus b, for n equals to 1 you'll get quotient 1, for n equals to 2 you'll get minus 6 as your quotient, and when n equals to 3, 36 is your quotient, right? So here you're having 1, minus 6, 36. We can say that the quotients belongs to, or the quotients are integers, right? When a, b are integers, then we'll get the quotients when a power n minus b power n is divided by a minus b. For n equals to 1, we'll get the quotient 1. For n equals to 2, we'll get the quotient minus 6. For n equals to 3, we'll get the quotient 36, right? So here, we can say that the quotients are integers. Then, our quotient q belongs to z and also lambda belongs to z. Okay? When a, b are integers, then the quotient obtained will belong to integers, provided a greater than b. You have to choose a which is greater than b. If you notice q belongs to z in any textbook, then a, b must be integers. And if you see q belongs to natural numbers in any textbook, then a, b must be natural numbers. So we have seen a problem from mathematical induction followed by examples. Hope you'll understand. We'll see you in the next video. Until then, bye bye.